Hello everyone, welcome back to edupediaword.com, your destination to free online education. In this video, we will be discussing the concepts of probability along with some questions like coin, die, cards and some other problems on the same topic. Friends, suppose we perform an experiment of letting a coin fall freely without any restriction or interference or hindrance. Then, when the coin comes at rest, the top face will bear either head or tail. Let us denote these two events by H and T respectively. Then, since we have not imposed any restriction on the coin, both of these events are equally likely to occur. And the probability of occurrence of any event according to theoretical approach is given as number of outcomes favorable to event E over total number of outcomes of the experiment. Now in our case, if we need to find the probability that the top face bears a head, then the number of outcomes favorable to this event is only this outcome. So we have 1 on the numerator, whereas the total number of outcomes are 2. Thus the probability that the coin will bear head is 1 by 2. Similar is the case for tail, because again the outcome favorable to tail is 1 and the total number of outcomes are 2. Let us have another example where we have a box in which we have 4 balls with their colors as white, orange, black and yellow respectively, such that they are of same size. We perform an experiment of drawing a ball from this box without looking at their position or location. Then the outcomes of such an experiment are either the ball will be white or orange or black or yellow. So let us denote the event that ball drawn is white by W, event that ball drawn is orange by O, for black let it be B, and for yellow let it be Y. So the probability that the ball drawn is white is given as the number of outcomes favorable to white, which is 1, over total number of outcomes, which is 4. Similar will be the case with all the colors, all the events. Such an event which has only one outcome of the experiment favorable to it is called elementary event. Since all of these events have only one outcome favorable to them, So all of these events are elementary events. If we add up the probabilities of all the elementary events, we will get 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4, which will be 1. In the previous case also, the favorable outcomes for the respective events of heads and tails was 1 and 1. So these are also elementary events. Again, if we add up these two probabilities, we will get the resultant as 1. In fact, it is true for all the cases. That is, sum of the probabilities of all the elementary events is 1. Now friends, let us again have the same question, that is a box containing 4 balls of same size with colors white, orange, black and yellow. One ball is again drawn at the random without looking at the location or colors of the balls. The possible outcomes will be, let us denote the corresponding events by W, O, B and Y for white, orange, black and yellow balls respectively. Then again the probability of the ball to be, say, yellow will be given by 1 over 4 as discussed in the previous case. Now suppose we are interested in the probability that the ball drawn is not yellow. The favorable outcomes to this event are these 3 outcomes. So the favorable outcomes are 3, whereas total outcomes possible of this experiment are again 4. So such a probability that ball drawn is not yellow will be 3 by 4. Friends, this probability is also denoted in symbolic form by P not Y. This symbolic form will represent the complement of this probability that the ball drawn is yellow. If we compare both of these probabilities, we can see that their sum will give us 1. That is, P of Y plus P of not of Y is equal to 1. Such events are also known as complementary events. And for an event Y, the probability of its complement is given by 1 minus P of Y. So in general way, for an event E, we can write P naught of E as 1 minus P of E. Friends, we know that probability for an event is given as number of outcomes favorable to E over total number of outcomes for the experiment. Now this numerator will be a subset of this total number of outcomes. Thus, numerator will always be less than denominator. Thus, we can say that this whole fraction will always be less than 1. And when the number of outcomes favorable to E are equal to the total outcomes, that is, at most, this value, this fraction can be equal to 1. Thus, we can say that probability of an event is always less than or equal to 1. And friends, also, let us have an example for this question. Let us say we want to calculate the probability that the color of ball is violet. That is, the ball drawn is violet. Now, from all these outcomes, we don't have any outcome favorable to this violet color. Therefore, the numerator will be 0. Total number of possible outcomes will be 4. Thus, we will get probability that the ball drawn is violet as 0. So, at the worst possible case, we can get this value as 0. Otherwise, it will be greater than 0. And the favorable outcomes can never be in negative. So, the least possible value of the probability for an event is 0. So, we can say that probability can be 0 or can be 1 or in between 0 and 1, but can never be less than 0 or greater than 1, and hence this result. Now, let us have some questions on the probability concept. Without looking into a bag containing 7 black balls, 10 red balls and 13 brown balls, we have 7 black balls, 10 red balls and 13 brown balls in a bag. A ball is drawn at random. Find the probability that the ball drawn is a first case of red ball, then black ball, and the third case of brown ball. Friends, let us denote the event that ball drawn is red by R. The event that ball drawn is black by B, and the event that the ball drawn is brown by B and small r. Then the ball can be among these 7 balls, and if the ball is among these 10 balls, it will be red. If it is among these 13 balls, it will be brown. So number of outcomes favorable to red are 10, number of outcomes favorable to black are 7, number of outcomes favorable to brown are 13. So the first probability that the ball drawn is red is number of outcomes favorable to red, that is 10, over total number of outcomes. Now consider that a ball is drawn, then it can be either red or black or brown and no other case. So the total number of outcomes are 10 plus 7 plus 13, that is 30. So P of R, that is probability that the ball drawn is red, is 1 by 3. Similarly for black, P of black is the events favorable to black, that is 7, over total number of outcomes, that is 30. Similarly for brown ball, P of brown is equal to outcomes favorable to brown ball, that is 13, over total number of outcomes, that is 30. So in this question, the statement is, a game of chance consists of spinning an arrow pivoted to the center of a disc, which comes to rest at one of the numbers from 1 to 12 of the disc, such that all these are equally likely outcomes. What is the probability that it will point at? We have different cases. So according to the statement, we have a disc with the arrow pivoted to the center of the disc. Let us connect an arrow to the center of this disc. Numbers from 1 to 12 are located on this disc. So we have numbers from 1 to 12 and all these are equally likely outcomes. So this arrow will spin and will come to rest at the end of each experiment, and we need to find the probability that it will point at 5, an even number, a number greater than 6, a number less than 13. So friends, consider that the arrow has come to rest, then it will come to rest pointing to any of these numbers. So the possible outcomes are 1, 2, 3, 4 and up to 12. So the probability that the number to which the arrow is pointing is 5 is given as number of outcomes favorable to 5. Only when the arrow will point to 5, that particular outcome will be favorable to this event. So only one outcome is favorable to this event, whereas all in all we have total number of outcomes as 12. So the first probability is 1 over 12. Now probability that it is an even number. The favorable outcomes are the cases when the arrow will point to either 2, 4, 6, 8, 10 and 12. So we have 6 possible outcomes which are favorable to this event, whereas total number of outcomes are 12. So this fraction can be reduced to 1 by 2, and hence the probability for this case, the second case, is 1 by 2. Now for the third case, a number greater than 6. The outcomes at which the arrow will point to a number greater than 6 are 7, 8, 9, 10, 11 and 12, which are 6 in number. So again we have favorable outcomes as 6 and total outcomes possible to this experiment as 12. So the fraction 1 by 2 is the probability for this event. The last event, which says a number less than 13. All the numbers are less than 13. So all the 12 outcomes are favorable to this event, and we have total outcomes as 12, and hence 1 is the probability of the fourth case. Now in this question the statement says a die is thrown twice. What is the probability that 3 will not come up either time? And in the second case we are asked to find the probability that 3 will come up at least once. Friends, a die is of cubical shape with 6 faces, such that each faces having the number of dots representing the values 1, 2, 3, 4, 5 and 6. So when we throw a die once, we have the possibility that the die will bear either 1, 2, 3, 4, 5 or 6. Now after throwing a die single time, the die is thrown again. So it can be the possibility that the first number was 1 and the second number is among the 6 numbers, that is 1, 2, 3, 4, 5 and 6. Or the first number was 2 and the second number as 1, 2, 3, 4, 5 and 6. Or the first number as 1, 2, 3, the first number as 3 and the second number as 1, 2, 3, 4, 5 and 6. Or the first number as 4 and the second number as 1 among the 1, 2, 3, 4, 5 and 6. Similarly for the other cases. Thus we can have all these as the possible outcomes. That is, in this column we have mentioned the outcomes with first value, that is the value at the first throw as 1, and then the value at the second throw as any of the values from 1 to 6. Similarly for these all cases. Now let us first calculate the total possible outcomes. Clearly, the total possible outcomes are these 6 values plus 6 from these plus 6 plus 6 plus these 6 outcomes and these 6 outcomes. That is, all in all we have 36 total possible outcomes. Now for clarification of this table, this value is actually 2 at the first throw and 6 as the second throw. Similarly, if you are talking about this value, it is 4 at the first throw and 5 at the second throw. So now let us calculate the total possible favorable outcomes where 3 will not come up either time. Or we can also calculate its complement, that 3 will come up either time. So let us denote the event that 3 will come up either time by say A. So favorable outcomes to this event will be this value, this value, and all these values, because 3 is coming up as the first position on the first row in all these values. Then we have this particular value where 3 is coming, here also 3 is coming, and here also 3 is coming. Apart from these values, none of the value has 3 as one of its number. So the total favorable outcomes to this event A are 1, 2, and these 6 and these 3 values. So we have 2 plus 6, that is 8, plus 3, 11. So the number of outcomes favorable to A are 11. In the first case, we need to find, in the first case, we are needed to find the probability of not of A. That is, 3 will not come up either time, whereas we have located the values where 3 will come up either time. So n not of A will be, or P not of A will be 1 minus P of A, because it is the complementary event of this event A. Thus P naught of A will be 1 minus P of A, that is 1 minus favorable outcomes to A, that is 11, over total outcomes, that is 36. So it will be 25 over 36. So this probability is 25 over 36. Whereas in the other case, the second case, we are asked to find the probability that 3 will come up at least once. So in this case 3 is coming at least once, here also 3 is coming at least once, and in the other case 3 is not coming at least once. So we have these two cases. In this column, in all the cases 3 is coming at least once at the first position. So all these 6 cases, this case also where 3 is coming at least once, in this column none other case is having 3 at least once. This case is also included. For the second case, this value or this position is also included. So in fact these are the favorable outcomes of the event A. So in the second question we are in fact asked to find the probability of A, which is 11, that is the number of events favorable to A over total possible outcomes. So the second probability, its value is 11 over 36. Now let us discuss a question on cards. The statement says a card is drawn from a well shuffled deck of 52 cards. Find the probability of getting an ace, a queen of red suit, a club card, a face card, a jack of hearts. Friends, in a deck of cards we have a total of 52 cards, where half of these cards, that is 26 cards, are black and half of these cards are of red suit. Among the black cards, 13 cards belong to spades with this symbol, and 13 cards belong to clubs with this symbol. In the red suit, we have 13 cards of hearts and 13 cards of diamonds. Among these 13 cards, we have 3 face cards in each of these 4 categories. The face cards are of Jack, Queen and King. Also, we have a card of Ace among these 13 cards. So, for a particular group of these, a particular set of these 13 cards, we have a card with the letter A, then we have the cards from 2 to 10, then the cards for J, Q and K. Similarly for all these sets. Now, if a card is drawn from a well shuffled deck of 52 cards, well shuffling means that all the outcomes are equally likely. So the total possible outcomes are 52. Now the probability that the card drawn is Ace will be number of outcomes favorable to Ace, that is, it can be the ace of this spade, it can be the ace of clubs, it can be the ace of hearts, or it can be the ace of diamonds. So we have 4 favorable outcomes. Thus the favorable outcomes are 4, whereas total outcomes are 52. So this fraction can be reduced to 1 over 13, which is the probability of the first case. Now for the second case, that is Queen of red suit. Friends, in red suit we have 2 queens. So the favorable outcomes are 2, whereas total possible outcomes are 52. Thus, the probability of the second case is 1 over 26. For the third case, that is a club card. Friends, we have 13 club cards. So, the probability that the card drawn from the well shuffled deck of 52 cards is a club card is 13 over 52, that is 1 over 4. For the fourth case, that is a face card, the favorable outcomes are Either we can have these 3 face cards, or these 3, or these 3 JKOK cards, or these 3 face cards. So all in all we have 3 into 4, that is 12 face cards. So 12 over total possible outcomes, that is 52, which is 3 over 13. For the last case, that is Jack of Hearts. Hearts have only one Jack, so the favorable outcomes when a card is drawn to be a Jack card is 1, and the total possible outcomes are 52. Thus here the probability is 1 over 52. So all in all we have the first probability as 1 by 13, probability for the second case, that is Queen of Red suit, as 1 by 26. For the third case 1 by 4 is the probability. For the fourth case the probability is 3 by 13, and for the fifth case the probability is 1 over 52. In the last question of this video, it is stated that in a game a coin is tossed 3 times and the outcome is noted. If all the tosses give same result, Ram will win. What is the probability that he will lose? Friends, if a coin is tossed, we can get either head or tail. Now again, if the coin is tossed, then if the first outcome was head, then we can have head or tail. So the sequence formed is head head and head tail. Similarly, if the first was tail, then for the first outcome as tail we can have head and tail. Thus the sequence formed will be first tail and the second as head, and the other outcome as tail and tail. Now if the coin is again tossed, then we can have an outcome that first 2 were heads and now we are having head, or the first 2 were heads, now we are having tail. That is again heads and tail for each of these outcomes. Thus for this case the sequence will be head, tail and head, tail and tail. Here we can have tail, head and tail, head and tail. Similarly tail, tail, head and tail, tail and tail. So the total possible outcomes are 8. Now let us denote with W the event that Ram will win. Now Ram will win when the coin is tossed 3 times, the outcome is noted and the toss gives us same result. That is, all the 3 tosses are giving the same value. Now this is the case when we are having the same value on all the tosses. Here it is a different value, here also it is different value, here again different value, here also it is different value, but here we are having the same values on all the 3 tosses. So there are 2 possible favorable cases for the victory of Ram. So the number of favorable cases when Ram will win are 2. Thus the probability that Ram will win is 2 over total possible outcomes. That is 1 by 4. But in our question we are asked to find what is the probability that Ram will lose. So, if the Ram will not win, then he will lose. Thus, we need to find the probability of naught of W, which will be 1 minus P of W, which will be 1 minus 1 by 4, or it will be 4 minus 1 over 4, which is 3 by 4. So the probability that Ram will lose is 3 by 4. So friends, that's all in this video on the concepts of probability and examples. Thanks friends for visiting edupediaword.com.